For building our KNN classifier, we need to be able to compute what is sometimes called majority vote. This means that given an array or sequence of votes, which could be, say, numbers 1, 2, and 3, we need to determine how many times each occurs and then find the most common element. So for example, if we had 2 1s, 3 2s, and 1 3, the majority vote would be 2. Note that while we need to count the number of times each vote occurs in the sequence, we will not be returning the counts themselves, but instead the observation corresponding to the highest count. Let's build a function called majority vote. We've previously programmed a function called countWords in our language case study, and I'm going to be using that as my starting point for the new function. Here we have the function that we wrote before to count the number of words occurring in a given piece of text. The new function is going to be called majority vote, and the input is going to be a sequence of votes. I'm going to delete this old docstring, which is no longer relevant, and we can also remove the pre-processing step here previously. Let's change word counts to vote counts. And we'll be looping over all of the votes. So for vote in votes, which is our vote sequence. Then we ask, have we seen this vote before? So if vote in vote counts. If we have seen this before, all we need to do is increase the counter, vote counts, for this specific vote. If we haven't seen this before, we will just add this to our counter. So vote counts for this particular vote is going to be set to 1. And we'll change this to vote as well. Let's try running the code that we have. So we'll define that function. And let's also enter some data. So votes is equal to, let's say, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's add a few more 3s in here. Then we can run the function by calling vote counts equals majority vote votes. We define a sequence, in this case a list, and then we count the votes. We can now inspect vote counts, and this is what we get. So the keys here are the different votes that occurred, and the values are the number of times each vote occurred. So for example, number 3 occurred 6 times. We've now counted the votes, and by looking at the dictionary, we can see that number 3 occurs most frequently among the votes. But how can we get Python to do this? Let's rephrase our problem. Given a dictionary where the values are counts, how can we get Python to return the key that corresponds to the largest value? Let's start with finding the maximum count. Let's first take our vote counts dictionary. We can ask, what is the maximum? In this case, the answer is 3. Note that running that is the exact same as running max of vote counts dot keys. This returns us the maximum key. If we wanted to find out the maximum of the values, we would replace .keys with .values, and we would know that the maximum vote occurs 6 times. If we wanted to then extract this bit of information in a variable, we could define, let's say, max counts to be equal to max of vote counts dot values. Let's move this code up in our editor for future use. We can now loop over all entries in the dictionary and find which entry or entries, in case there are many, corresponds to the maximum count. We can do this using the items method of dictionaries. Let's first make sure we know how the items method works. For vote, count, this is a tuple in vote counts dot items. Let's just try printing these out. So we can print out vote and count. This for loop will now loop over the dictionary, and for each entry, it's going to be printing the key and the value associated with that key. We can use this as a starting point for our code. I'll create an empty list here called winners, and in this list I'll be keeping track of the keys that correspond to the highest values or counts in the dictionary. I'm going to keep track of maximum counts, so I'm going to move this line here, and then we're ready to loop over our dictionary. What we'd like to know is the current entry we're looking at, does that have the maximum number of votes? So if the present count is equal to max count, we can append to winners our vote. Then we can get rid of this line here. Let's try running this. In fact, let's change this. We have a small typo. Let's move this to max count. Now we can try running this, and the code runs. Let's see what we have in our winners. In this case, we have just one winner, which is number 3. In case of a tie, we can just pick one of the winners at random, since any option is just as good as any other. Let's make this modification, and let's also turn this code into a function. The first step we need to do is we'll import the random module. The first few lines of the code will remain as they were, although we have to move the return statement further down. I'll then take my code here, where we pick the winner. Make sure to indent the code, and let's see what we have. Reading from the top, we first set up vote counts dictionary. Then we go through all of the votes and we count the number of votes each candidate receives. Then we keep track of the winners, and the final thing that remains to be done is to return the result, which is going to be winners. But remember, in case we have multiple winners, we want to be able to just pick one of them uniformly at random. This is why we call random.choice on our winners, and as a consequence, our function will return just one winner, even in the case of a tie. Let's next try running our function. I'm going to move this window to give us a little more space here. I'll mark the function. We'll run all of this, and luckily no errors. We can then run the previous example again. We'll first redefine votes, and then this time the function is going to be returning a single winner to us. Now let's try running this line. And in this case, our winner is number 3. I'm next going to add 3 more votes for number 2. I'll redefine that. And let me just take out this one, the assignment. And we can now try running the function a couple of times. This time number 3 was the winner, this time number 2, now 3 again, and so on. So we see that the function is doing what we wanted it to do. In case of a tie, it picks one of the candidates, one of the elements, uniformly at random, and returns one single winner. As you may remember, the most commonly occurring element in a sequence is called mode in statistics. Finding a mode is a common statistical operation, so we could use a shortcut approach here. Let's try Googling how to find the mode of a NumPy array. How to find the mode of a NumPy array. In this case, the first hit looks right. In the SciPy module, there is a function called mode, which accomplishes exactly what we want to do, which is finding the mode of a sequence or an array. Let's use this function in our own function. Let's go back here. In this case, I'm going to take my existing function. It's a good starting point for our new version of the function. And it turns out that I will not need most of the code here. The first step for us will be to import scipy.stats as ss. And we can take the function that we had. In fact, we can delete essentially everything of our function. We'll be calling ssmstats.mode. We'll be calling this on votes. And if you look at the documentation for the function, you'll see that SciPy returns, the mode function returns both mode and the corresponding count. The final thing left for us to do is to return the mode. This is a short version of this program. I'm just going to call that majority vote short. And let's complete this by adding a docstring. Return the most common element in votes. I'll make sure to add this docstring also here above. Remember, our rule was it's better to write some documentation now rather than postpone writing a docstring later. Let's try running our code. We can use our existing example here, and the code appears to work. The function majority vote short is both short and fast, but if you run the code several times, you'll see that it always returns number 2. This makes sense given the documentation for the mode function. It's useful to know that finding the mode of an array can be done very easily and quickly, but in this case we will stick to our function majority vote. That's because when 2 or more elements are tied, we'd like to pick one of them at random.